Hi and welcome to my review of the JGAurora A5 printer. I received this printer for free from JGAurora in exchange for a review, but this review is entirely my own unbiased opinion. I already have 3D printers I am happy with. I don't need another one. And my goal today is really just to help you guys explore this printer, have the right expectations of what you'll be getting if you decide to buy one. I've been dabbling with 3D printing for about 6 years now, so it's not my first printer, and this is the 5th 3D printer that I've personally owned, and I've been using it now for about 4 weeks fairly solidly now. So 4 weeks is not very long, but it's hopefully enough time to get a fairly reasonable impression of what the printer is capable of. Firstly, JGAurora, you might not have heard of them before. They are pretty new to Western markets, but this is not their first printer. They've been popular in China for quite a while now, alongside competitors like G-Tech, stay well away from them, or Wanhao, who are the ones who made the printers that were sold in Aldi. As for JGAurora, their printers are generally of pretty good quality. I'd say they're one of the leading manufacturers in China of good 3D printers. However, I have 3 problems with JGAurora that all center around bad communication. So I'm going to address that first, and then we're going to get onto the printer after that. Firstly, JGAurora, they've continually had problems with their website being out of date. They were advertising this printer as coming with like smart filament recognition and like a magnetic removable bed, and none of these features ever made it into this printer. But those features were advertised on their website until like a week ago. So yeah, this really out-of-date website. There's very little documentation. If you're a beginner to 3D printing, this might be a good printer for you, it might not, but there's no documentation to help you really get started for a real beginner. I think that's really lacking. There's no clear place in their website to download the latest software, to download the latest firmware. A lot of the documentation is in really poorly translated English. Just the low quality of their written communication makes this more difficult than it has to be for Western buyers. Secondly, a lot of people have had trouble getting help and support for their printers. These printers are really low margin products, and to make them as cheap as possible, they try to package them into as small a box as they possibly can. Unfortunately, this is a large, big, heavy printer, and for many buyers of the A5, they've arrived with some kind of damage, be it like broken cables, snapped motor couplers, bent frames. My printer itself arrived with a slightly bent frame, no other major damage. My friend, also in Melbourne as well, he's arrived with a bent frame and broken motor couplers. And I've seen people with broken heater beds, broken other parts. It's just a real shame. Like, it's so frustrating when you get your printer, you unbox it and you gotta set it up and you find this damage. It's like, oh, so disappointing. And I'm particularly concerned about the number of people on social media that are actually having a hard time getting replacement parts for the shipping damage. I mean, seriously, JGAurora, just send them out, make your customers happy. If you're going to cut corners on your shipping costs by making poorly packaged products, it's going to bite you twice. You're going to get unhappy customers, and you're going to have to pay additional shipping costs for those spare parts. Like, it's just, if they packaged it with a bit more, like just taping things down that can move around, putting more hard foam in there, that kind of stuff, I think people would have a better experience out of the box for what can be a really easy setup. The third problem I have with JGAurora is that their early units often have problems that are sometimes fixed in later models, but those early buyers are never told about what changes have been made, and they're often stuck with those early models. The earliest A5s that were shipped had a whole lot of 3D printed parts in the corners, on the frame, inside, and these parts failed pretty consistently, either during shipping from the rough handling or fairly soon after printing. Some people have had luck getting replacement parts made of metal sent out to them. My printer came with metal parts for the most part, but some people haven't, and it's really inconsistent. I experienced this myself. I have a JGAurora Z603S printer that I bought fairly soon after it came out. My printer had a few flaws and defects, and I was not aware there was upgrade parts available until I contacted them to pay for some replacement parts, and the parts I ended up getting were of much higher quality. I was like, what is this? What have I been missing out the whole time? So yeah, when you buy this printer, you really have no idea what upgrade they're going to have done to your printer before you receive it. And it's really hard if you're looking at different websites. You have no idea whether the printer they're selling is old stock, that it's lacking those features, or if it's a one straight from the factory with all the latest goodies. It's really hard for me to review this printer because I don't know what printer you'll end up getting. Really, that's the biggest issues I have with JGAurora. So finally, we can get on to talking about the printer. Here we go. So firstly, the printer comes practically pre-assembled. There's comes in two halves where you have the gantry system and the main body. I've got an unboxing video showing how you can put it together in under about 10 minutes or so. It's very, very easy. 4 screws, plug a few things in, and then it looks ready to print. I got a decent, lucky cat print out of it, but we expect a bit more than that in 2018. The star of the star of the show is this printer's amazing huge print volume. You've got this 320 square print, 300 square print head and about 320 high. It's about a 300mm cube, which is just an enormous size for printing like helmets in, or other cosplay parts in, or there's really going to be very little you'll find won't fit in this printer's print volume. However, this large size is one of this printer's best and also worst features. The large size of this printer, that large size places a much higher demand on the precision and the rigidity of the machine that is required than, I'd say, a much smaller printer. And it's here where this printer starts to run into problems. I'm going to start by talking a bit about the large printing bed. The large printing bed is a sandwich, which is a 4mm glass plate with this coating on top of it, which is then stuck down onto a 1.5mm aluminium, yes, it's aluminium, not aluminum, aluminium plate with the PCB heater element on the bottom side. This glass surface is coated with what JGAurora are calling a black diamond coating. This is marketing grandishness. It's really just a fancy name. It seems to be just a fancy name for glass frit, which is that black stuff you can see often in the corners of like a car window or a bus window, around the edges. And what it is, it's a ceramic paste they paint on or print onto the bed and then bake to give you this hard coating. And they've done a nice pattern on this. Yeah, it's far from being McDonald's secret sauce or the 11 KFC herbs and spices. It's you can buy glass with this coating already on it commercially. It's not too hard to find. As for the coating itself, I find that the parts stick well. They're easy to remove when it cools down, provided you get your first layer print height right. If your nozzle's too high off the bed, you won't get the filament being pushed into the bed surface, and you won't get good adhesion. If your nozzle's too close to the bed, you're going to have problems with the extruder because the Bowden's set up and they're quite fussy as well. So really you have to, it's a lot of tweaking to get that first layer height set correctly, and once you do, the prints stick pretty well. I've only tested PLA on this printer so far. They stick pretty well, and then when they cool down they pop right off. Yes, you can use things like glue stick or hairspray, but I mean really it's just kind of like using a spoon to eat your lunch because you can't be bothered to wash your forks. If you dial in the layer height right, which takes a bit of time, you can get some good adhesion to make printing pretty easy. And for prints that don't stick well, you can always do things like adding a brim, and I've found good luck with that for small parts. So you have this sandwich with this glass stuck onto this aluminium plate. The problem with this sandwich is the glass and aluminium expand at different rates. Aluminium expands about 5 times as much as glass does. So going from say 20 degrees Celsius to say 65 degrees Celsius, which is 68 Fahrenheit to 149 for you medieval folk in Fahrenheit, over this temperature change the glass will expand by about 50 microns. With aluminium plate it will expand about a quarter of a millimeter. So when the bed is heated, the aluminium plate expands and the glass expands a little bit, which leaves you to the bed to start to warp and bow. Just a little bit, but over a bed this large, it starts to become a problem. This warped bed is made even worse by how they actually attach the glass to the aluminium plate in the factory. What they do is they assemble the printer, put the aluminium plate on, and then just stick the glass down on top of it. It's not very precise. If the aluminium plate is warped in their assembly and you put the glass on top of it, you're going to be trapping that warp into your printing surface. What they really should be doing is heating both the glass and aluminium up to the 60-degree printing temperature of the bed, then putting the glass on a flat, fully supported surface, applying the aluminium plate to the bed on that flat surface just to make sure everything is dead flat at the printing temperature, so that'll help compensate for warping due to temperature changes. and then put the whole bed assembly on the printer. Yes, when the bed cools down it will warp, but when you heat it back up again it should come back to that flat surface, or at least as close as you can get. That improved manufacturing process would have probably helped a lot with avoiding these warped beds that people have been getting straight out of the factory. On top of this, the aluminium they have actually used is what's known as cheap rolled aluminum. You get a large block of aluminium, you put it through 2 giant rollers, like a pasta sheet maker perhaps, and that puts a lot of stress inside the material. And the problem with that is that stress remains there, and when you start to heat the material up, those stresses play and the bed will start to kink or warp in different ways. There are better aluminium materials you can buy, like cast aluminium, which is produced and then milled or cut or sawn to avoid having those stresses in the materials. And those those cast aluminium plates you can buy, they don't warp anywhere near as much as a rolled aluminium does. And better printers use those. I would be happy to forgive the cheap bed construction and the poor assembly, because it's all in the name of time saving and cost savings with this printer. If it wasn't for one thing they should have included, and that's a bed leveling probe. So I'm not a big fan of bed leveling probes. I feel like they're a compromise for having warped bed or warped geometry, but if you're going to make a cheap printer, a bed leveling probe is a cheap and easy solution to make calibration of the first layer height really, really easy. And in 2018, there's really, I don't think, any excuse for it not to be on this printer. I think it's a feature that this printer really lacks. For beginners especially, it makes everything so much easier. And it really would have been the difference between this being a okay printer and a good solid printer, for me at least. JGAurora have included a feature they call semi-automatic leveling control. What this is, it's pretty basic. All it is let me bring this up here. The print head moves to some different positions on the bed for you. And then you're expected to manually level it yourself, entirely manually level it yourself with these tiny little dials in the corners. They're really hard to reach to. Let me turn that off. They're really hard to reach around this corner. Around here, you have to reach around the filament spool, and it's really difficult to access. It's nowhere near semi-automatic. It's entirely manual with the assisted moving of the head. And unless your hand's like President Trump's and really tiny, it's really awkward. Yes, there are mods people have done to add an automatic leveling probe to the bed. It's great if you're technically minded, but I don't think it's great that people should have to open up and tinker with their brand new printer out of the box just to get a good flat printing surface. So mesh bed leveling with a probe means that the printer then knows the warping of the bed and can compensate for that to make sure that the first layer height is correctly set across the bed. And without some kind of probe, you can do it manually, but it takes a very, very long time. And it's probably my biggest criticism of this printer is that it lacks a bed leveling probe. Okay, let's now talk about the build quality and construction of this printer. Firstly, I'd say the metal arms that support the bed. This bed's a huge sheet of glass. It needs to be held dead flat. It needs to be kept. It's moved back and forth very quickly. It needs to be held there rigidly. And these arms are not really what I'd call adequate for this kind of bed weight, moving at this kind of speed. They're sheet metal, but they're kind of thin and flimsy. Yes, sheet metal. Oh, it's metal. That must be terribly strong. You could make a printer out of aluminium foil and call it an all-metal printer. It does not quite have the same ring to it. They're just not thick or robust enough, I think, for a bed this size. And when you're printing quickly and this bed is moving back and forward, the whole printer rocks a bit, which is not going to do anything good for your printing quality. You end up with ripples and other defects in your part. It's kind of like these arms, this printing bed arm here is actually only supported in this little middle region here. These arm regions are unsupported, and it's only connected through to the middle of the printer in the center section here. So it's a bit like a diving board effect, where jumping on the end of the diving board, the whole thing wobbles up and down a bit when you're moving back and forwards. On my printer, it's actually a bit more rigid than it is from the factory. I've replaced the bed leveling springs with these fixed nylon washers and have really tightened those down, and that makes my printer bed actually a lot more rigid than it used to be. So if you're looking to make your printer more rigid, I'd recommend this as a good solution. The rest of the frame is all sheet metal, which is good. It's a lot more rigid than, say, a cheap acrylic frame, which the budget printers have. In the A3S printer, which is basically the same printer in a smaller size, I'm sure this frame is plenty rigid enough. It's a smaller size, it's going to be less lighter components moving around, but in a printer this size, I think you need to have stronger joints and thicker metal and a significant upgrade to the strength and rigidity of the frame. And it's basically the same design as its smaller brother printer. If you have a small joint down here, say, and there's a little bit of play and a little bit of movement in that joint, in a small printer, that will translate to a little bit of movement, but not too much. In a printer this size, when you're printing really high objects, that wobbling is not really, I say, acceptable on a printer this size, and I think you'll start to notice those those vibrations in your prints when you print at high speeds. The factory firmware comes to set up to print quite quickly. We've developed a custom firmware for this printer that really slows things down, especially in the movement on the bed y-axis, to really help compensate for the vibrations that come from the weaker frame and the big moving bed in this printer. I think this moving bed design is probably a bit flawed as you scale your printer size up, because you get a more and more heavy mass that moves around. Probably in a printer with a large print volume, I'd probably personally prefer a printer that has a bed that moves up and down only, and then it has an XY moving print head, like say a Tron XY X5S is another competitive printer. I think a printer this size, this design of bed is not really ideal. Let's look at the different axes. I'll show you those quickly. The y-axis for the bed is it grinds a bit. It's not really very smooth, and I've seen some rippling in the prints early on. I think it may have worn in a bit perhaps now, but it was pretty grindy out of the factory. I think the bearings they're using are cheap, or perhaps the internal rails the printer runs on are not perfectly straight. The x-axis is excellent, really, really good. No complaints at all. They've got nice, good-sized round rails for the printer to run on, round rods. The movement is really, really smooth. All of the supporting components are machined aluminum. It's really impressive. Probably my favorite part about this printer is these nice, high-quality machined aluminum components that are strong and well designed. I think they're compact, they're light, they're strong, and precise. That's exactly what you want. The z-axis, the vertical axis, it's okay. I have no major complaints, except that these long rods can tend to vibrate and shake a bit as you move up and down quickly, and you can get some of the squealing and shaking if you move those up and down too quickly. But they're accurate. As long as your rods didn't come bent during the factory, during shipping, you should have a reasonably good time with the z-axis. I think that's about all I had to say. Oh, the extruder. The extruder has a Bowden extruder with a stepper motor mounted to the frame. The Bowden system works reasonably well. I think they could have used a shorter length of Bowden tubing to increase the to reduce the length of filament that has slack, because it's pushing the filament from this side here through the entire tube down to the hot end. So you have the filament can compress and act like a spring slightly. So the shorter your Bowden tube, the less of the spring effect you'll see affecting your print quality with rippling in your surface finish. The hot end itself, it's a pretty good system overall. The hot end temperature is completely out of whack from factory. It's about 10 degrees, 10-12 degrees too cold from the factory calibration. With our custom firmware, we've made a much more accurate calibration for that. But otherwise, if you're using the factory calibration, you're going to be printing PLA at like 230, 225 degrees Celsius, which is a bit ridiculous. So that's something we've fixed. The cooling as you're printing, you want to have a fan blowing out on the tip of the nozzle at the part below it to cool the filament as it's coming out of the hot end. The nozzle on this printer is pretty terrible. That being said, it's a 3D printed component, and there's lots of other designs on Thingiverse, so you can easily download one of those, print it out, and upgrade your printer yourself without too much trouble. So I'm not going to ding them too heavily for that part. I'm sure JGAurora will improve their design of their nozzle and will include that on their new printers as well. At least they should. The rest of the frame is pretty solid for the most part. There's a few more things to mention. These silly white panels, they look kind of cool. You've got these sports speed holes, but they're held in with hot glue. and they rattle like crazy when you're printing. It's yeah, it does no favors for the noise of this printer. And really, this is a giant hole in the frame of your printer. Like, you're just making your printer weaker. I don't see what this actually adds to it. It's just a cosmetic thing, a decision that I don't personally agree with. I think it compromises the strength of the printer, and it's a bit unnecessary. The whole printer is metal, which is good. The downside of that is it's a bit like a tin can when you're a bit rattly, I mean, it's pretty stiff, but it's just a little bit too. It's not as quiet as some of the other printers I've used. Even aluminium frame printers I found can be quieter than this printer. Okay, that's the frame and build construction. Okay, now finally let's talk about the electronics in the A5. This printer actually has two motherboards. There is the main motherboard, which is back located in the middle section of the printer. That's an MKS Gen L motherboard. MKS are a cheap manufacturer of motherboards, not always the greatest quality, but it's a pretty solid design from what I can see, and there's good documentation out there. It's an off-the-shelf motherboard you can buy on eBay if your one breaks, and it has replaceable stepper drivers. So if you damage your stepper driver from, say, disconnecting a wire while the printer's happening by accident, or something else happens, you can just replace that stepper driver. You don't have to replace the whole motherboard. So you're replacing like a $3 stepper driver versus replacing a $50 motherboard. It's a really good feature to have, those removable stepper drivers. That also means you can upgrade your stepper drivers. You may have heard the whiny sounds coming out of my printer before when I was showing you the bed leveling process. I'm testing out the TMC 2130 stepper drivers in this printer at the moment. Just put those in last night. I haven't got them dialed in quite right yet. They're very noisy and very whiny. The printer comes with Lego A4988 stepper drivers that seem to work pretty well out of the box. They're not too noisy. They're just they're typical, reliable steppers for printers to use. So I think overall the main motherboard electronics are pretty good. The only thing I'd like to have seen would be some kind of fan to give some active cooling over those stepper driver heat sinks. That would have been nice to see, I think. The main motherboard talks over an internal serial connection to this front LCD module, which is also an MKS module. It's an LCD module they have made with a nice touchscreen interface. The device has its own separate firmware, which is different to the main motherboard firmware. So when you upgrade your firmware, you really have two separate parts you can change, which makes things a bit more confusing. You upgrade the ports on the side. I'll show you these for a second. There's a USB type, I think it's type A or type B. There's two different USB ports on here. One is for a USB cable to go to the computer, and one is a USB port to plug in, say, a USB stick. The USB stick port goes directly to the front motherboard. The USB cable port goes directly to the main motherboard. You can print from either of those. You can print from a computer or you can print from a USB stick. However, the front LCD motherboard module is the one that's responsible for things like detecting when the filament runs out, detecting when the power goes out, and resuming that from the correct position. Those features are only provided by the front LCD motherboard. So if you're printing off a USB stick, you get all those features. But if you're printing off, say, a USB cable to your computer and your power goes out, you won't get any of those features. Your printer will fail, the printer will fail, and you'll turn it on again and it'll have no idea because the front motherboard has not been involved during that printing of that file. This is kind of an oddity that they have as a result of using those two motherboards. I'm a bit disappointed by this, to be honest, because JGAurora, they've made their own motherboards before. My printer comes with a custom motherboard that they designed, and it works pretty well. I feel like they could have made their own motherboard for this printer, and it would have given them a unique selling point for this model. But I mean, I like it personally. This is an off-the-shelf module that I can buy if my one breaks. And JGAurora doesn't put out any documentation on their printers, so the fact that this is an off-the-shelf printer, I can go look up the pinouts, look up the details, and that's a great thing for the tweaker or the hacker, at least. Yeah, the MKS motherboard in this, they're not a great manufacturer, but it's not a fire hazard, unlike the old ramp star motherboards. The power supply in this printer is excellent quality. It's a genuine Meanwell branded power supply. They're a very good power supply company. Highly recommend them. It's just a bit underpowered for a printer this size. They're using a 350 watt printer power supply, which I think is a good size for a smaller printer For a printer with a 300mm cube volume, I think you need to go up to a 450, 480 watt power supply to get the bed to a hot enough temperature for things like ABS and to keep it there if you're, say, printing in a cold room. I can get the bed on this printer to about 110, barely, in my room at about 25 degrees Celsius ambient temperature with no fan blowing on it. As soon as I start to put the fan to cool the part, or if the room temperature drops lower, it really struggles to get there. The power supply is just a little bit underpowered for a printer this size. The wiring inside is really nice. It's a bit of a mixed bag. The internal wiring is nice, it's very professional, nice and tidy. They're using a proper drag chain on the y-axis, which is really nice to see. They've got silicone wires, which are really good for high flexibility. Big tick there, JGAurora, on your internal wiring. It's really nice and neat. Cable tied, things are crimped nicely. The x-axis wiring is a bit poor. These cables, this cable here for the, I'm not sure if you can see this, but there's a cable here for the x-axis motor, and it kind of it's just loose. It's not great. And then the printer heater cable, the printer bed heater cable, comes out right at this point. So every time the bed moves back and forward, it catches on the x-axis motor cable. I mean, this is an obvious design flaw that they really should have fixed out of the factory, but they obviously didn't care and they shipped it as it is. It's like, what? Why do that? The inside's great. This kind of stuff, it's a bit naff. The hot end wiring, it's only okay. Ignore the tape. I've been modifying things and tweaking things. Out of the box, it comes with just a single cable tie holding this plastic shroud over the cables. The strain relief is really not, in my opinion, it's not really good enough for a printer that's going to have a hot end that moves this much. I think they should have used either another drag chain or had a better method of strain relieving at this point. This head will move back and forward hundreds of thousands of times over the life of this printer. So if there's a bit too much kinking happening at any particular point, it makes it much more likely you have a wire fail or a wire break, which is a real hassle then to repair wires that break in your printer. It's not fun to disassemble a whole lot of things and solder wires, and it's just a nightmare. So preventative design through better strain relief would have been good to see on a printer like this, especially a printer that's designed for beginners with very little technical ability to be able to put together quickly. You should make it so it's very little difficulty for a beginner to be able to service your printer as well. And I think this design is cutting a corner there on the quality of that wiring, layout and design. The best printers on the market today, they use things like flat flex cables or unpluggable cables, so when they die you can just unplug the whole cable, put a new one in, and away you go. This one here, it's a solid wire all the way through to the plug on the side, so if you want to replace a section of cable you have to really unsolder a whole lot of things. That's a real hassle. Okay, so in summary, I've given a pretty critical eye to this printer. I hope I've really shown you the complete picture. I hope you have no surprises if you decide to buy one. My goal is to really make sure that you can make the best choice for your needs. Most people who have received this printer have overall had a good experience with it. Those that have had negative experiences, most of those have been due to shipping damage and difficulty getting replacement parts sent from JGAurora, which is a bit odd. JGAurora really needs to improve their packaging. Needs to be a lot more rigid, needs to be protected a lot more from drop damage. Parts need to be more rigidly held in the packaging so they don't move around. Extra padding would prevent things from being dinted and bent. And I think that if they improve that, that would give a much better experience that would eliminate most of those common issues from damaged parts. The printing quality, I really haven't touched on this much. It's pretty good. Out of the box, the results were okay. They weren't great. The firmware from the factory is completely out of whack. You want to be delivering a precise amount of filament to the model as you're printing to avoid having gaps in your printer or avoid having too much filament and having blobs. This printer from the factory comes extruding 40% too little filament. So we've prepared a custom firmware for this printer. We've accurately calibrated it to improve that, and that's improved the printing results dramatically. Without the custom firmware, I'd say this printer prints probably on the poor side of things, just because of how poorly the firmware is configured for this printer. I'm still tweaking a few things, and I might do a video in a month or so just showing some of the results you can achieve with a fully calibrated JGAurora A5, and showing some of the modifications I've done to improve the printer quality as well. There's a pretty good community around this printer already. Many good ideas and improvements people have been doing. They've been publishing those, showing how to do them, showing where to get parts from. The printer runs on a firmware called Marlin, which is an open source project. JGAurora has taken a copy of that, they've made changes to it, and they won't release and they refuse to release their source code. I don't understand why they would do that. The firmware they're using is terrible and poorly calibrated, but they refuse to share their work, which is disrespects the open source community, and it's against the rules of using an open source project in a commercial product. You have to supply the open source firmware if you use that in a commercial product. The hot end temperatures are the main issue, because you might try printing it at temperatures you're used to on another 3D printer and you'll get terrible results out of the box. But as long as you heat up the temperature high enough, the out of the box factory firmware does work, and you can get some okay prints with it. But it's when you put the custom firmware on it, the results improve dramatically. We've been able to reduce the speed of things moving up and down, so they accelerate more smoothly, reducing ripple. The custom firmware lets you really tweak this printer to exactly how you want to use it. Personally, I think the A3S is probably a better printer for most people. The smaller size makes the frame seem more rigid, which will alleviate many of the problems with wobbling or rippling in prints. Unless you really need the huge print volume, save the $50, get the smaller printer. Or get the big one and maybe do something like add the bed leveling probe. That'll make your bed calibration a much easier process. Or just get a different printer altogether that comes with a bed leveling probe. As far as pre-assembled printers under $500 are concerned, I think JGAurora is trying to offer a very competitive package. The color touchscreen, the large print volume, they all sound like great things. It's a shame about the bed leveling probe, because otherwise I would have recommended this printer pretty unconditionally. Personally, I'd recommend either paying more money for a pre-built machine with that bed leveling probe, like a genuine Prusa i3, or perhaps going a DIY route, like a Tron XY X5S. A DIY printer, you assemble it, it's your printer then, you know how it works, you know how to put together, and those DIY printers tend to be a lot easier to modify and tweak and change as you learn and want to upgrade your printer. A big benefit of the kit option is it really trains you in how to service and maintain your printer, which I think is important for printer owners to really to know how to do those kinds of things. I'm going to put some links to where to buy some of the printers I mentioned in this article in the description. These are affiliate links, they help me out if you want to use them, so thanks if you use those. If there's anything I've missed or any other questions you think I haven't addressed, feel free to put comments below, and I'll try to answer those and address any major questions you have. Anyway, thank you for watching this video. I hope this has been an eye-opening video for people considering the JGAurora A5. It looks like a nice printer. It's got that nice print volume. I have some concerns about the rigidity of the print, and the warped print bed makes things a lot more difficult, I think, than they have to be with the lack of that bed leveling probe. So thank you for watching, and have a great day.